We're now on page 56, example number 4, and the questions on page 54 have to do with sketching graphs of the function based on the criteria that's given to you. So in this question I have three things to put into my graph. For the very first statement, this is pretty much the point 0, 0. So let's go ahead and plot that into the graph right there. So there it is, the origin. And then let's go ahead and look at the two limit statements. When x is going to infinity or negative infinity, you should be thinking about horizontal asymptotes. Alright, so you have a horizontal asymptote of 2 when you go all the way to the right. So I will go ahead and just put a dashed line here, because as I go to positive infinity, I guess the graph is leveling off at a height of 2. And if I'm going to negative infinity, I'm approaching a height of negative 2. So I'll go ahead and draw a horizontal asymptote here. This is y equals to negative 2. And I'm approaching negative 2 when x goes to negative infinity. Okay, so something like that. All right, so that's the answer for that graph. Let's move on to the second one. All right, so this time I have 4 things to consider. I will go ahead and do this one first because that's just a coordinate. That's going to be 0, 3. So let's go ahead and plot that over here. Okay, next one I have, well, this is kind of interesting. It's just saying that we have a horizontal asymptote of 0 when I go to positive and negative infinity. So I'll go ahead and put a horizontal asymptote right here, this blue line right there. And finally, for my next line, I have a few more limit statements, these one-sided limit problems. So they're both approaching 0 from the left-hand side and the right-hand side. So here's a 2 here. So that's a height. This is your y value. So I will put an open circle at 2 because since there's a closed circle over here, I will go ahead and have an open circle on the vertical axis here. And I'll do the same thing at a height of negative 2. So at negative 2, I'll put an open circle. And it states that when I'm approaching 0 from the right-hand side, I reach that height of 2. So here's my right-hand side, and I can just approach the height of 2 there. And then over here, as I approach 0 from the left-hand side, I'm approaching a height of negative 2. So I can do something like this. Alright, so hopefully if you take a look at that and just pause the video, I'm sure you guys can write in the right limit statements and everything should be fine. I'll go ahead and actually write the limit statement on the graph. So the limit as x approaches 0 from the right-hand side of f of x, that's approaching 2. And the limit over here as x approaches 0 from the left-hand side of f of x, well, that equals to negative 2. All right, let's move on to the next graph. All right, so question number 3. For question number 3, I have another coordinate right here, so that is the point 0, 2. So let's put a solid dot right there. Okay, so now I have when x goes to infinity, it's approaching a height of negative 2, so that is a horizontal asymptote. So let's go ahead and draw a horizontal line right here. Okay, so I'm not 100% sure how I want to set this up yet, but let's go ahead and take a look at the rest of the graph here. This part right here, as x goes to negative infinity, I go to a positive y value. So I guess the graph is shooting up like that as I go to negative infinity. Okay, and let's take a look at this last part here. The limit of f of x, as x approaches 0, I reach a height of 0. So that's probably on the left hand, the right hand side, because it's just approaching 0. So okay, so as x is going to positive infinity, I need to get very close to this height. And if x is going to negative infinity, I need to sorry, that didn't come out very well. I was just trying to say that as x approaches negative infinity, the graph needs to like shoot up like that so that it satisfies that condition right there. So I guess the graph would kind of look like this and level off like that. And as you can see, the limit as x approaches 0, which is this point right here of f of x, that equals to 0. So both the left side and the right side are approaching 0, so this graph would satisfy that condition there. Okay, let's go on to a few more problems here. We're now on page 57, and in page 57, example number 5, we need to find the equation or equations of the vertical asymptotes, and we need to use limits to justify our answers. All right, not too bad. The first thing I recognize is in these graphs, you should go ahead and actually write down where the vertical asymptote is. So for this very first graph, the vertical asymptote is at x equals to 2 just by inspecting the graph. And then all you have to do now is write a limit statement. So the limit would be as x approaches 2, which is that guy right there. And if I approach it from, in this case, I guess it's approaching 2 from the the left-hand side, then this graph is going to a height of negative infinity. So there's your limit statement right there, and that verifies that you have a vertical asymptote at x equals to 2. All right, let's move on to question number 2. And for question number 2, the very first thing you should do is visually find the vertical asymptote, which is x equals to negative 1. Then write a limit statement to verify that we're going to positive infinity and negative infinity. All right, so we need to have two limit statements. We need one limit statement as x is approaching negative 1 from the right-hand side. Now, if I'm approaching from the right-hand side, here's the right-hand side, that's going to positive infinity, so that equals to positive infinity. And then I need another limit statement as x approaches negative 1, but this time I'm approaching negative 1 from the left-hand side. And if I'm approaching negative 1 from the left-hand side, it's also reaching a height of negative infinity. And there you go. You have two limit statements to verify that your vertical asymptote is at x equals to negative 1. Moving on to question number 3. Once again, for question number 3, visually find the vertical asymptote, and the vertical asymptote is at x equals to negative 2. Now, although there's two pieces of the graph right here, I don't need to write two limit statements because both the left hand and the right hand limit are approaching positive infinity. So I can just simply write the limit as x approaches negative 2 of f of x, that equals to positive infinity, and that's good enough for this particular question. All right, let's move on to question number 4. And question number 4, I have two vertical asymptotes. So I have a vertical asymptote at x equals to negative 1, and I also have another vertical asymptote at x equals to 2. Now, I will go ahead and write the limit statement for x equals to 2 first, because both the left hand and the right hand side are approaching negative infinity. So I don't need to write the left hand and the right hand limit because both of them are approaching positive infinity. Now, for the vertical asymptote at negative 1, I will write two limit statements because the left hand side is going to positive infinity and the right hand side is going to negative infinity. So the way I write that is the limit as x approaches negative 1 from the left hand side of f of x, that's going to positive infinity, and the limit as x approaches negative 1 from the right hand side, that's going to negative infinity. All right, so those graphing questions aren't too bad. Let's move on to example number 6. Example number 6, not too bad because there's not a lot of algebra for questions like this. We're given a graph and we need to find the following limits. Okay, let's do this. X approaches 0 from the left, so here is 0, and I'm approaching it from the left-hand side, so I am reaching a height of positive infinity. Next question, I am approaching 0 from the right-hand side. So this is the graph that I should be following. If I'm approaching 0 from the right hand side, the height that I approach is going to be 1. And since the left hand and the right hand limits are not equal, the limit at 0 will be does not exist. Okay, let's move on to the next row. Let me just erase the colors here if I can. Get my eraser out. Great. Okay, so let's move on to question number 4. Now I'm approaching 3 from the left-hand side. So here's 3, and if I'm approaching it from the left-hand side, the height that I'm approaching is positive infinity. If I'm approaching 3 from the right-hand side, I need to use this part of the graph and follow 3 to from the right, and I go to negative infinity here, so this answer will be negative infinity, and this answer does not exist for part 6 because the left hand and right hand limits are not equal. All right, let me just erase those colors there, and let's move on to number 7. As x goes to positive infinity, so positive infinity is over here, and if I go to positive infinity, I'm reaching a height of 1, so my horizontal asymptote is 1. And then for number 8, as x goes to negative infinity, so negative infinity is over here on the left-hand side. If you follow the graph, if I go to negative infinity, forever to the left-hand side, the height that I approach is negative 2. So this is negative 2 here. And this is also a horizontal asymptote, and this is also a horizontal asymptote. All right, let's move on to page 58 now, number 7. Number 7... questions 1, 2, and 3. These ones aren't too bad because we're just sketching things. Now this point right here, that's just a coordinate. That's just 1 comma negative 1. So 1 comma negative 1's right there. And this point right here is negative 1, 1. So that's going to be over here in green. Okay. And then we have a few limit statements here. So if I'm approaching 0 from the left-hand side, I go to positive infinity, so that kind of looks like this, right? That's my positive infinity right there to match that guy right there. And if I'm approaching 0 from the right-hand side, I'm getting to a height of negative infinity, so I should go like that. Approaching 0 from the right-hand side, I get negative infinity, which matches that. Okay, so now I can erase these guys. And let's finish off the last statements here. I will bring out a red color here, and okay, so if I go forever, so this is saying if I go forever to the right and left, the height that I approach is 0. All right, so if I go forever left, then I'm approaching a height of 0, and if I go forever to the right hand side, I'm also approaching a height of 0. So that satisfies all of the conditions there. All right, let's move on to question number 2 now. Alright, so I have some weird stuff here. So this is really 5 comma 0, and this is negative 2 comma 0. So let's go ahead and let's plot those points there. So here is 5 comma 0, and here is 2 comma 0. Okay, let's move on to the next statement here. So as I'm approaching 3 from the right hand side, I go to negative infinity. And if I'm approaching 3 from the left hand side, I go to positive infinity. Okay, that's kind of interesting there. Okay, so since I'm going to positive infinity and negative infinity, these are vertical asymptotes. So at 3, let's go ahead and put a vertical asymptote right there. And if I'm approaching 3 from the, okay, so 3 from the, let's do the right hand side first. I'm going to negative infinity, so maybe the graph looks like this. All right, so that's the limit as x approaches 3 from the right hand side of f of x. That's going to negative infinity. And if I'm approaching 3 from the left hand side, I'm going to positive infinity, so maybe something like that. So that blue part, this is the limit as x goes to 3 from the left-hand side of f of x equals to positive infinity. All right, so that second line is all done now. Now let's go on to the third line. What's happening over here? Okay, so as x approaches negative 1, I go to negative infinity. Okay, so this is a vertical asymptote. Again, anytime you go to positive or negative infinity, it's a vertical asymptote. So at negative 1, let's put a dashed line at negative 1, because there's a vertical asymptote there, and we're going to negative infinity from both the left hand side and the right hand side. So if I just bring out a blue marker here, I'm going to negative infinity there from the left, and if I go back to my other graph, I can just draw whatever and just go straight down. So this is the limit as x approaches -1 of f of x equals to negative infinity. And finally, the last step is this piece right here. If I go forever to the left, I level off at a height of 1, so that's my horizontal asymptote. So here's 1. So yeah, this one's pretty easy. It just goes like that, and then you're done. Okay, so that's question number 2 done. Let's go on to question number 3 and finish these questions. Okay, so let's start with the very first one right here. As x approaches 3 from the left-hand side, I go to negative infinity. So this right here is a vertical asymptote because of the negative infinity. So here's 3. I will draw a dashed line. And if I'm approaching from the left-hand side, I'm going to negative infinity, so something like that. Okay, and let's move on to, you know what? I should have actually done this green step first here because these are all points. So that's -2, 0, -1, 0, and 1, 0. Let's go ahead and let's plot those points first. Yeah, that actually helps because then I can just erase my first graph and redraw it so that it actually goes through the x-intercept of 1, 0 there. Okay, so if it goes through this point, whoops, back to red here. Okay, so maybe something like that. Okay, and let's see now here. If I go, I think this middle step, this second step I'll do last, and I will attack this third step, the last step here. If I approach -1, I reach a height of -1. So, okay, so that means the graph needs to go through this height over here somehow. Okay, so, oops, so maybe I'll go like that, and like that. Okay, so that just confirms that the left-hand side and the right-hand side, sorry, when I say left-hand side and right-hand side, they both approach a height of -1 there, so that satisfies that condition. And then I can do this last step here, a height of 1, so the graph can just go like that, and then I'm done. Alright, so that concludes this video. Thanks for watching.